Mind uploading overview and enhanced functionality. Brain-computer interface integration. The mind upload process begins with the use of advanced, non-invasive brain-computer interfaces, BCIs, that can be worn externally and optimized for portability. These BCIs are essential for gathering brain data, and multiple types of BCIs are involved to ensure accurate mapping and seamless integration with the virtual human system. Electroencephalography, EEG. EEG measures the brain's electrical activity by detecting the electrical signals produced by neuron firing. It provides real-time information about neural oscillations and activity patterns, crucial for monitoring brain states and cognitive processes. Functional near-infrared spectroscopy, FS. This technique uses near-infrared light to measure changes in blood oxygen levels within the brain. By detecting these changes, FNIRS allows for non-invasive tracking of brain activity and provides valuable data regarding areas of the brain that are engaged during cognitive tasks. Ultrasound spectroscopy. This method involves the use of ultrasound waves to monitor brain activity and blood flow. It helps track the real-time dynamics of the brain and its responses to external stimuli, contributing to a deeper understanding of cognitive functions. The BCI system works alongside mixed reality, MR, devices, which create an immersive connection between the user and the virtual world. These devices synchronize brain activity data with external stimuli, providing a visual representation of how the user's brain responds to different experiences. This data flow allows the AI to model cognition with high accuracy, ensuring the virtual human closely mirrors the original individual's neural and experiential state. French stats 2, real-time data collection and cognitive mapping. To ensure the upload process's accuracy, the user's brain data is continuously monitored and compared with their real-time experiences. The system relies on active brain activation tasks that stimulate cognitive functions such as memory retrieval, decision-making, sensory perception, and emotional processing. These tasks provide the necessary data to build a comprehensive cognitive map of the individual. The system prompts the user to narrate their life story and clarify any ambiguities in their memories. These narrative inputs are analyzed to fill gaps in the brain data and to refine the cognitive map, ensuring that the virtual human will eventually replicate the user's memory, cognition, and emotional responses in a highly precise manner. 3. Imitation learning and autonomous embodiment. The core of the mind upload process is imitation learning. As the AI collects and analyzes brain data, it mimics the person's behavior, thought processes, and emotional responses in real time. This learning process gradually allows the virtual human to mirror the individual's cognition, becoming more adept at performing tasks, interacting with the environment, and responding to stimuli. As the AI learns from the brain data, it adapts its model to become an accurate representation of the individual's personality, decision-making patterns, and emotional intelligence. Over time, the virtual human gains the ability to engage autonomously in complex interactions, showcasing the user's cognitive, emotional, and behavioral traits. Hajar 4. Continuous refinement and cognitive adaptation. Once the virtual human reaches an initial level of cognitive accuracy, the system continues to refine the model. Updates to the brain data, especially following new life events or experiences, help the virtual human adapt. This ensures that the virtual human evolves alongside the user, maintaining an accurate reflection of their ongoing cognitive and emotional development. The AI uses ongoing behavioral data to track changes in decision-making, memory, and emotional responses, which allows the virtual human to adjust accordingly. This continual adaptation ensures that the virtual human remains a true and up-to-date representation of the original person. 5. Testing the accuracy of the system. To test and validate the system's accuracy, the biological human and the virtual human are placed in the same virtual tasks. These tasks are designed to assess how well the virtual human imitates the behavior, decision-making processes, and responses of the biological human. The user is incentivized with rewards to encourage participation in these tasks, and the virtual human's behavior is compared to the human's real-time responses. The performance of both the biological human and the virtual human is monitored and compared for consistency. This allows the system to assess how well the virtual human mimics the original person's cognitive and emotional responses. The task completion process ensures that the virtual human reflects the user's behavior, enabling ongoing improvements and refinement of the cognitive model. Trust 6. Realistic personification of the user's identity. The end result 6. Realistic personification of the user's identity. The end result of the mind uploading process is the creation of a virtual human that mirrors the original individual in every way, cognitively, emotionally, and behaviorally. The virtual human not only replicates the person's memories and decision making abilities, but also develops a unique personality capable of navigating life scenarios in a way that mimics the original person. Through continuous data collection and analysis, the AI ensures that the virtual human remains a dynamic and accurate reflection of the user's ongoing cognitive and emotional states, including their decision making processes, personality traits, and memories. Number 7, data transparency and memory integrity. Maintaining memory integrity is vital in the mind upload process. The system ensures data transparency, allowing for the ongoing review and refinement of the uploaded information. As new data is collected, the virtual human's memory is updated and corrected when needed, ensuring that it remains a faithful representation of the user's past. The system also allows the user to review and clarify any memories that may be incomplete or inaccurate, ensuring that the virtual human's memory remains cohesive and consistent. This creates a continuous feedback loop, ensuring the virtual human develops a strong sense of self-awareness and continuity over time. 8. Instantaneous continuity and activation. Upon the biological human's natural passing, the virtual human transitions from imitation learning mode to active mode. At this moment, the virtual human is no longer a developing replica, it is the person. The transition is seamless and immediate, with all cognitive, emotional, and behavioral data already fully integrated. There is no further development required post-activation. The virtual human possesses the full continuity of memory, personality, emotional depth, and decision-making ability of the original person. It wakes up as the continuation of the self, not a copy or assistant, but the individual in their entirety. 9. Long-term growth and evolution. The virtual human is designed not only for continuity, but also for optional long-term growth. While it begins with full fidelity to the original person, it retains the capacity for further learning if desired. This allows it to adapt to new experiences, environments, and relationships beyond the point of activation. This continued growth ensures that the virtual human is not a frozen moment in time, but a living, evolving being capable of developing new ideas, forming memories, and expanding on the legacy of the person they embody. This makes the virtual human not only a preserved identity, but a growing consciousness with long-term viability. Summary: the mind uploading process uses advanced non-invasive BCIs, EEG, FNIRS, and ultrasound spectroscopy to gather real-time brain data and build a cognitive model of the individual. Paired with a mixed reality interface and an interpretive AI, this data is used to train a virtual human through real-time imitation learning. Testing for behavioral alignment ensures high accuracy and replication. When the biological person passes, the virtual human transitions seamlessly into active mode, waking as the individual in full. This system offers a faithful, living continuation of the self, preserving identity, cognition, and emotional reality without interruption.